Yeah, just put the formula, set the objective function, and you vary the parameter, then you can get the epsilon A and B. And when you know the epsilon A and B, you can get the mole fraction of each fish. And the objective function that you have is the equation A and B in the slide. And I have already put the equation for you in the spreadsheet as well at the equation 1 and 2 here. Okay, and the pressure of the system is 20 bar. I put into this range. And this is the gas constant in the unit of mole per Kelvin. And this is the value of the delta GF or standard if energy of formation at the different temperature. So at the different temperature, you must have the different equilibrium constants. And finally, I want you to plot the graph with like this. Can you try to do it by yourself? And one more thing is the value of epsilon or the reaction coordinate can be negative as well. Can be positive or negative. It doesn't need to range between 0 to 1. And how to determine the limit of the reaction coordinate, you can see from the equation of mole fraction here. So for example, the epsilon A here, you know that the mole fraction is the value ranging from 0 to 1. It should not be negative. It should not be over unity for the mole fraction. So in the case of the epsilon A here, it can be 0.5 maximum. If it's 0.6, it will cause the value of the mole fraction carbon dioxide here is negative. Right. So the maximum limitation for the reaction coordinate for reaction A will be 0.5. And so you have to consider from the equation of the mole fraction to determine the limitation of the reaction coordinates. For reaction B here, it can be 0 to 1. That's it. And this one. So I will give you some time to do the calculation by yourself first. Let's start with the temperature 1000 first and see if you can determine the mole fraction of this epsilon or the epsilon A. The procedure for the other temperatures is the same. You can use the Excel to do the work for you. What I ask you to do now is to determine the equilibrium constants, and the final goal is to determine the epsilon A and B. And we have the objective function that we derived so far in the lecture slide that I have shown you previously as the equation 1 and 2. So it means that the procedure after this is just the mathematics, or just input the formula into the spreadsheet. That's it, and just solve it. The epsilon A and B here will be the guessing value. And we set the objective function as the equation 1 and 2, and we want the solver to change these two values until the equation 1 and 2 is satisfied. In this case, it should be equals 0 for both equations. So can you determine the equilibrium constant?